Okay, now we've started. Uh, you made it. Thank you. Good job. Uh, posted practice test two. I know it was late, but it was worth the wait, I think. I hope. And so we'll go through that today, and then I'll see you for test two on Thursday. I posted it here, but I'll pull it up in my notepad anyways. Let's see here. Let's see. Just like test one, I've got a list of core concepts. Of course, I can't possibly test you on all of these things, but it's a nice kind of outline of all the things that we've done, right? And so test two is only on chapter six, which is financial math, which you guys are really loving, I think. And then chapter seven, sets and counting, which I actually do think you're enjoying more. Um, Steve looked over my shoulder and said, "Are you just giving them the whole textbook?" And I said, "Yeah, basically." So this will be your formula sheet for this test, just because there are so many things and so many components that can be overwhelming. And so make sure that you kind of get to know this formula sheet. It's, I think, 3 pages long. Um, and I'll try to remember to reference it whenever I can in the questions so you can see the linkage. Okay. Um, but yeah, sets and counting. Yeah, just the last page there. So you'll have this, but you'll need to get to know it before the test. Otherwise, you'll just spend the whole time reading, and that sounds terrible. Reading. No one likes that. Let's see if I can. My screen was falling asleep. There, it's better. Um, okay. So it starts off, it's in order, simple interest, compound interest. I did keep the test in order as well, and so you can kind of work through it methodically. Might be nice. Um, if you can think of any other uh, yeah, reading. Ugh. It's fun because this is the only time where I can read the chat, so kind of fun. Um, and so what was I saying? Oh yeah, if you can think of any formulas that are not on here, well, you can rest assured it's probably not on the test because I made sure that they're all there if you need them. So okay. Um, and some that you don't. I'm not gonna test you on compound interest. Oh, remember the fun or compound int oh, continuously compounded interest. I won't test you on that. It's on here, but I'm not gonna test it. Nope, nope, nope. But I'm not gonna write that down because it's there. You can do it. Um, remember the fancy typesetting that I was so proud of before last day? So notice how this is a gradient from dark to light. That actually took a lot of work. So yeah, you'll have this exact same formula sheet on the test. Um, thank you, thank you. Amazing gradient. Yes, yes. I know. So pretty proud of myself. All right. Shall we? Hopefully you had some time to pick away at some of these questions, right? And if not, we'll go through them, but you'll have the recording as always. So if I'm going too fast or whatever, or you need to make a star, make a note. I need to go back to this. Okay. All right. First things first, if an amount of $2,000 is borrowed at a simple aha. right? Simple interest rate. That tells me I have to be in the simple interest section of my formula sheet. So let me grab that. Do, do, do. Ooh, it's too big. Hey, this should be equals. I don't know how that happened. Bad start, Emily. Bad start. And actually, I don't know how that happened. Paste. How much is the interest? That's the amount of the interest. Uh, and so how much is the interest? I'm solving for I. That's a bad typo. I'm going to fix that. Luckily, I haven't sent it to the printers, or else I'd have to draw lines on every single one. Yikes. And I need probably more room. So, what are we given? We have an amount, a principal amount of 2,000. Okay. And we have the interest rate. So R is 0.10, right? A percentage. We have to divide by 100 to get it to the rate. And for 3 years means that T is 3. Okay. I, hey, equals, nope, PRT. Here we go. 2,000 times R, which is 0.10, times T, which is 3. Plug them all in. Some things I'm looking for on the test include, okay, I want to see the empty formula that you're using, right? And then I want to see it all plugged in. And then usually it's easier to just go through and do the calculation. So you are allowed to skip to the final answer here. Okay. But I do want to see the first line and everything plugged in where it's supposed to be, and then the final answer. Okay. And so I get I, which is the amount of interest, and I'll just do it here on the slide. I should have Martha Stewarted these, had them all ready to go. I did not. I get an even $600 in interest. Seems like a lot, but it is 10% for 3 years, so ugh. Unless nope, that's right. Okay, nice. Any questions about that one? Pretty good. Got a thumbs up. That's cool. Okay. How many marks do we think that should be? I would say 2. Oh, what? How about 2? I think just telling me that you know which formula to use, that's worth something. Right? Half a mark here, half a mark here. I don't know. Should probably just be 1 mark, but 2 marks is nice. I like to inflate the easy ones, and then you can kind of get 3 marks. 1, 2, 3. No. All right. John borrows $2,400 for 3 years at 9% simple interest. Right? So we're still in that simple interest section. How much will he owe at the end of 3 years? It's a party. Uh, how much will he owe? Right? That's the accumulated amount of the loan, which is kind of a bummer. It's better if we've made a deposit, but let's go back to our simple interest section. Okay. And we've got the total amount A, also called the accumulated value or the future value, is given by this formula. And so maybe I'll grab the whole thing. Copy. I thought I did such a good job pasting these in already, but I already need way more space. So, oops. Okay, so this is from your formula sheet, right? It's our job to know that how much will he owe means to find A, right? That's probably the hardest part in this case. The principal amount borrowed in this case is 2,400. T is 3 again. That's boring. I guess it's technically no different than any other time frame, but and then at the end of 3 years, which we already have. So we want to find A, which is P times 1 plus R times T. P, 2,400 times 1 plus 0.09 times 3. You can check in and jot down some math, but maybe what I'll do is I'll zip to the end so that you can see kind of the bare minimum amount of work that you need to show. And so 0.09 times 3 is 0.27. No, you know what? I'm going to use a different color because I can. Because I don't want someone reading this and being confused later. 0.27, right? Do the 0.09 times 3 is 0.27, and then add it to 1. This is optional work shown. Well, it's not optional. You still have to do it, but you don't have to show it. And then 1.27 times 2,400, I get 3,048 is what he would owe. He only got 2,400 though. Yikes. Okay, nice. I'm gonna need more space. I always need more space, I guess. There. The city library has ordered a new computer system costing $158,000. The system will be delivered in 6 months, and the full amount will be due 30 days after delivery, which means a total of 7 months. How much should be deposited today into an account paying 7.5% compounded? Okay, we've moved on into the compound interest section. Compounded monthly to have 158,000 in 7 months. Okay? And so we need to have an accumulated amount of 158,000 in 7 months. Okay? So let's make note of what we have. We have A, or maybe I'll just say that this is A here. Okay. The time frame that we're working with is 7/12 of a year, right? TSV in years. We had some weird practice problems where as long as the interest rate and the payment or the length of time kind of match, then it's okay. You don't have to turn it into T, but for the test, I think it's a lot easier to just turn everything into T. And in this case, we have to, or in years, I should say. In this case, we have to anyways. So T should be in years, was the end of that story. R is 0.075. And if it's compounded monthly, then N is going to be 12, right? 12 times per year. Okay. How much should be deposited today? That's a P. That's a P. Fine. I can't actually remember if I wrote out. Oh, I wrote out some of the things and not all the things. It's interesting of me. But we want to find P. Okay, so we're in the compound interest section. What's the difference between the compound interest section and the annuities section? The annuities section of your formula sheet has a regular payment, right? That M, that payment amount, right? Here, I'm not seeing any regular payments. We're just talking about, okay, I take a lump sum and it has to grow to 158,000. So what does that lump sum need to be, right? And so that puts me here. Paste. So we want to solve for P in this equation. Okay. I'll jot down my formula. A equals P times 1 plus R over N to the N times T. I just realized we forgot to give marks for the other one, but I would do 2 marks here as well. I tend to mark on a 2-mark scale most efficiently. 2, you did it. I move on. 1.5 is like, you kind of got it. Something happened. 1, so close. You halfway there. And half for breathing on the paper. Did you write anything down at all? So that's my marking scheme. Scheme indeed. Okay. Let's see here. We plug in our values and then we're ready to go. 158,000, right? The hard part is figuring out that that is your A, right? The amount that we're kind of aiming for. I should make this look like 8 is P, which we're trying to solve for. Times 1 plus 0.075 over N, which is 12, to the power of 12 times 7/12 of a year, right? 12 compoundings per year for 7 months. And so I get 7 compoundings, right? If you could just kind of talk yourself into that. And so N times T is always going to be the number of compoundings that you're letting it sit there for, right? And so 7 makes sense in this case. Okay. Let's simplify this. And I'm not making it optional. Notice that. It's kind of optional. Fine, I'll make it the optional color. I'm trying really hard to be consistent with my colors on this one, but it's really hard for me. Okay. 0.075 divided by 12 is very small. Plus 1. Also very small, but bigger. point 0 or 1.00625 to the power of 7. Making sure you keep all your decimal places if you can. Ideally. It is money, so it is going to make a difference usually. 1.0445789111. And solving for P, I get 158,000 divided by this 1.0445789111. So I do want to see that step, which means, this step is just for you for jotting things down, but I see everything I need to see here. Can I give myself just one more line? Oof. It's a big task, isn't it? Sort of. I just need one more. 158,000 divided by that previous answer. Oops, I get a P of 151,257.1222, which is money. If you kind of forget to round to 2 decimal places there, I'm not too concerned about that, right? But you could say P must be in dollars. 151,000, looks like a 7. 257.12. Nice. Okay. That was a little bit more involved. We could keep it at 2 marks or we could make it 3 marks. 2 marks kind of downplays the effort, but it's a little bit more wiggle room if something goes wrong. Work, effort, kindness. Put that on a t-shirt. 3 marks. The effective interest rate. Oh, I guess interest rate. Okay. So we have an account paying 7.2% compounded quarterly, which means our N is 4, right? And so here we have, it's the same colors, a rate of 0.072, and it's compounded quarterly. And we want to find the effective interest rate, which you don't really need to remember because it's just asking you for the effective interest rate, but that would be the same dollar amount that you would get if it was compounded annually, right? So it just takes the 7.2% and it's being compounded quarterly. Well, that's worth something if it was compounded annually instead, and it's going to be slightly different. So that's our job to find. Okie dokie, artichoke. Go to our formula sheet. And notice that we have 2 effective interest rates, right? R subscript effective is the effective interest rate, but it also says effective interest rate, right? The effective interest rate. Okay. You want to choose this one, right? Because it's compounded quarterly. If it was being compounded continuously, it would have to say continuously compounded, right? Which you could do. You can, it's the math is even simpler, right? And so that's nice, but not on this test. We'll do this one. Oh, so we want to find the R effective, right? The effective interest rate. And so here we go. The effective interest rate is 1 plus R over N to the power of N minus 1. Okay. Rita's gonna have to wait. There we go. I've got my R and my N, and that's really all I need. So the effective interest rate is gonna be, oops. Hey. Hey. 1 plus 0.072 divided by 4 to the power of 4, then minus 1. You'll see why it has to be minus 1, because otherwise it's going to be 100 and some odd percent, and you don't want that. That's bad. Okay, let's see here. 0.072 divided by 4 plus 1 is 1.018 to the power of, oops, to the power of 4. Okay. Is this optional? Fine. I'll make it optional. Optional work. There. Light blue. Put that to the power of 4 and subtract 1. Right? Otherwise, it's 107%, and no bank is going to agree to that unless it's on a loan. Then they would be happy. But we would quickly be bankrupt. I get 0.07396743298-ish. Keeps going. Nice. I think you can leave it there. If you want, you can do some rounding, but I'm good with leaving it there. Right, 7.396743298%. Right. This is feeling like a 2 marker. 2 marks. It's feeling a lot like a 1 marker. Oh, 4. We'll meet in the middle at 2. There's like 3 things to keep track of. And you have to know which formula to use. There's that. Okay. Show it, making it a percentage. I guess that could be worth something. No, because it's a test situation. You're going to be all stressed out. What if you forget? I can't make it worth marks. No, no, no. At the end of each month, Rita deposits $300 in an account that pays 5%. Now we've got these payments, these regular payments, right? And so now I have an M of 300, right? That's probably the most most important part here. So at the end of each month, right, there's a regular payment, making it an annuity. Um, I'm not going to, on test two, we're not going to have annuities due, which were payments at the beginning of the month or the beginning of the quarter, because it just uses a slightly different formula and that's, eh. And so they'll all be at the end of the month or it won't say. And so you can ignore that section of your formula sheet. Heard it here first. Uh, but at the end of each month, Rita deposits $300. Okay. And so this makes it an annuity. Into an account that pays 5%. So R is 0.05. Notice that it doesn't say how often it's compounded, and that's because we've only been working with situations where it's being compounded at the same frequency as the payments, which means that our N must be 12 week, right? Monthly payments. And what will the final amount be in 4 years? So the final amount, that's your accumulated amount, right? Or your future value. And here we have T is 4 years. We'll go snag our formula sheet here. Right? We've graduated to page 2, and maybe what I'll do, clever, clever. I'll copy it so I don't have to run so far. Put it here. Put her there. Okay. So the future value of an ordinary annuity, that's where we're working because the payments are just at the end of each month. Okay. Whereas an annuity due is if we have payments at the beginning of each payment period. Okay. But we have payments at the end, and so it's all good. Okay. Has to be this one because I want to find A, right? And so the last option that we have, if we have decided, okay, the payments are at the end of the payment period, okay, so that means it's not an annuity due. So then my other option is this one here. But notice there's no A here. I can't solve for A. We use this setup to solve for the present value, right? Or the principal amount, right? If we want to, with regular payments, right? So we can either find the present value of an annuity or the installment payment for a loan, right? And so that's when we use this setup, which we will, don't worry. But for now, I can't remember if I grabbed this already, so I'll grab it again. Since we're solving for A, it has to be this formula. Okay, a little bit bigger, but we can do it. Huh? So we want to solve for A. I'll write it out again, just so we can see it. M times 1 plus R over N to the N times T minus 1 over R over N. Now it's just a matter of plug and chug. Solve for A. I have 300. It's my regular payment, my monthly payment. And 1 plus 0.05 split amongst the months is what we're doing there. Divided by 12. And then how many compoundings? 12 is our n times t, which is 4, and then minus 1, divided by 0.05, divided by 12. Okay. I'll do it as optional, but I'd love to see, some of these steps, but I guess you don't have to, because sometimes it's hard to kind of take a pause and jot it down. Sometimes that's less efficient than just getting to the final answer. So I understand. 0.05 divided by 12 plus 1 is not very nice, but I'll jot it down anyways. 1.00 4166 repeating to the power of 12 times 4. 12 times 4 is 48. Now I lost it. 0.05 divided by 12 plus 1 to the power of 48. Okay, got that. Then I'm going to have to subtract 1 divided by 0.04. I have to assume it's 0.004166 repeating, because the other one's 1.004166 repeating. Okay. Let's take this to the power of 48. You get 1.22, blah, 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 and then minus 1. I know I'm getting impatient. Math. 0.220895355 divided by 0.004166. Repeat. I'm going to multiply it by 300 and divide by 0.00. I'm actually going to divide by this fraction, this 0.05 divided by 12, just so I can keep all my decimal places, utilizing some brackets. I get A is 15904.46556. If I round to a dollar amount, I get, whoops, not 19. That'd be nice. 15,904 and 47 pennies. Three. 3 marks. Oops. Yes, question. I'll keep an eye out. Uh, yes, you can. Um, I wonder if it's just in the setup. Because if you've done any sort of financial math in the past, they tend to use different formulas. But if you got the same answer and you're kind of plugging in all the same values, then that should be fine, right? But this is what you'll have on your formula sheet. So just you'd have to memorize your other one. But there's, yeah, a couple of different ways that you could write it. That's fine. So if you've got it memorized, that's cool. Okay. This was number 5. Mambo number 5? Which I used to think was the greatest song ever made. Okay. Let's see here. I sense I'm gonna need a little bit. Mambo number 5. Yeah. Mm-hmm. My taste in music has changed since, but the first time I heard it, I was like, wow, this is the greatest song ever made. All right. We're about to level up here. Uh, a firm needs to replace most of its machinery in 5 years at a cost of $500,000. The company wishes to create a sinking fund to have this money available in 5 years. How much should the quarterly deposits be if the fund earns 8%? So now we're making quarterly deposits. Okay? And I need to end up, right, at the end of all this, I need $500,000. Okay? And so I guess the quarterly is separate, but uh, I need to find out what my M is. Okay? And so we'll pick apart, and I remember it doesn't really, the PDF tends to cut it off at the edge, I guess. Okay. So we have 5 years to do it. So let's jot that down. T is 5. And I need an accumulated amount of $500,000. Um, the term sinking fund I find a little bit confusing because we sink money into it and then have it at the end. I don't know. I guess. It doesn't really make sense. To me, a sinking fund would be decreasing, but it's not. It's increasing. Okay. Ba, 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 ba. Quarterly. N is 4 times per year. And the rate, which we assume is also compounded quarterly, it simplifies things. Yeah. Yeah, pirates sink the fund. I don't know how that would help you, but there. Okay. It's the same formula that we just used, right? So this one's kind of a hot commodity. Okay. You can talk yourself into why is it not an annuity due, right? Because it would have to say at the beginning of every quarter, right? And so it would have to say at the beginning, right? If it doesn't clarify, then you can assume it's at the end. Okay? And so let's see here. So now we want to solve for M and we have A, and so the rest is very similar to what we just did, right? Just with an additional step, I would say, of solving for M. Okay. And so we plug in our values. First, I'm going to write out the formula I'm about to use. M times 1 plus R over N to the N times T minus 1 over R over N. Plug in my values. My A is that goal amount that I have of 500,000. M is what I'm trying to solve for. And I have 1 plus R, which is 0.08, divided by N, which is 4, to the power of 4 times, I have 5 years to do it. Oops. Make that look like 5. And then don't forget that minus 1. I almost did there. Hey, look at how aggressive my eraser is usually. There. Divided by R over N. 0.08 divided by 4, which is kind of a nice one. Okay. So I'll do some, you don't have to show this work, but I don't want you to be lost if you're reading through my solutions. But I will pick up the pace a little bit and just simplify everything in here. Okay. And so I'm going to do 0.08 divided by 4, which is 0.02, and then add it to 1, and then take that to the power of 20, and then subtract 1. Okay. And so I do 0.08 divided by 4. Phew, it is 0.02. Plus 1 to the power of 20 minus 1. Okay. So I'm going to jot this down. Can't see. 485947396 divided by 0.02. If I divide that by 0.02, I get M. I know, pulling a fast one here. 500,000 divided by this chunk. Uh-oh. I know, maybe I pulled a fast one. I didn't mean to. Just kind of impatient. 24.2973698. If I divide 500,000 by that, 1, 2, 3 zeros. 20,578.35906. It's money. It's all around to 2 decimal places. Oh. Nice. Okay. This one's similar to that set for life example that we did, right? Is it better to receive $400 each month for 6 years or a lump sum of 25,000 today if the interest rate is 7%? Explain. Oh, oh, and I forgot to give you marks for this one. I guess I don't really give you assign marks. It's a solid 3. I think you're catching the vision of my mark scale. A little bit harder. Picking up what I'm putting down. Nice. Okay. Is it better to receive 400 each month for 6 years or a lump sum? So you've got 2 options. Okay. Now, the key here is to figure out what the present value of $400 each month for 6 years would be, and then we can compare that to 25,000, and then you just pick the highest one. Okay? And so that's going to be the problem solving route that we take for this one. Okay? And then the explanation is I like to pick the one with more money, and so I chose this one. All right? And so if you want to visualize it, now you don't have to, so I'll do it in an optional color, but if you want to visualize it, here we are today. Right? And maybe 6 years later, right? If I get 1 month, 2 months, for 6 years, there's 72 months, right? 71 months. I have the option of getting $400 a month but that's worth something, right? That's worth P today. Okay. So those are all worth a total value of P. Okay. And so that's what we need to solve for, right? And then we want to compare that to 25,000. P versus, and then we compare P versus 25,000. Right, and pick the highest one. Okay. I definitely need more room. I'll just add a page. Huh? Okay. So you don't have to draw it out, but I do find that it's a little bit uh, more helpful to visualize it. Okay, but that's hard, so you don't have to. Okay. All right, where's our formula sheet? Where do we need to be? If I have to solve for P and there's regular payments, right? For regular payments, I'm choosing between these three options, right? And so, but there's only one with a P, right? And so it means that we've got hardly any more financial math questions to enjoy, but also it means we have to use this formula, right? Beep. Oh, there it is. Okay. Let's see here. Add a page. Now I'm flush with space. Huh? I'll jot down what we've got here. M is 400 each month. So N is 12. And I've got 6 years, so T is 6. And then don't let that 25,000 confuse you. I guess an alternative solution you could, although I feel like it would be more work. You could figure out, okay, well, 25,000 today would give me what monthly payments and then compare them, right? You're doing the same thing, but I think it's easier to draw them back to P and then compare them today. But that's an alternative way that you could solve it. Okay? But your conclusion should be the same. All right. Okay. But, and then the interest rate, we need the interest rate, 0.07. Okay. All right. Solving for P. Okay. Now, I don't really know versus P. Maybe I'll do that. I don't know. It's not really obvious where to put the P question mark, but that's okay. All right, put it on a fresh page here. P times 1 plus R over N to the N times T is M times 1 plus R over N to the N times T minus 1 over R over N. Okay. Plugging in our values. All right, I'm trying to solve for P. Maybe I'll give myself a little bit more room here. Trying to solve for P. 1 plus R was 0.07 divided by N, which is 12. 12 times 6 years. We already did that math, right? We saw that we would need to have 72 payments, right? And so that's all we're doing with N times T. is equal to m, which is 400 times 1 plus 0.07 divided by 12 to the power of 12 times 6 minus 1 is 0.07 divided by 12. Okay. So, a little bit bigger, but just take your time, right? And you can notice that this chunk multiplying the p is actually the same chunk that you have over here, right? And so you don't have to necessarily do it twice, but you can save it in your calculator, right? But I'll do it twice probably. Showing off, I guess. 0.07 divided by 12 is very small. Plus 1 to the power of 12 times 6, which is 72, I get 1.5201055504. I will store that. And this store A is more of a note to myself because you don't know what I've stored anywhere. Oops. Okay. Now I can take this value, right? That's this whole chunk here, and then I can just subtract 1, right? Multiply by 400, and then divide by 0.07 divided by 12. Okay. And so I'm going to subtract 1, times it by 400, and divide by bracket 0.07 divided by 12. Use brackets, so you can just do it. You can just do it. 35664.37743. Okay. Now I want to divide that by what's stored in A, and so I want my P, and maybe I'm back to 35664.37743 divided by 1.5201055504 divided by recall A. I get a P of 23,000. I think my choice is clear here. Compared to 25,000 today, right? I would choose 25,000 today. Okay. And like I was saying, you could take this 25,000 and split it up over monthly payments, and they should be more than 400, right? Because it's worth more today. So, and you have to explain. If I ask you to explain, you have to explain. That's another mark, though. Since 25,000, it doesn't have to be crazy, is more than 23,461.78, but that implies that you understand that that's the value today of those monthly payments is more than 23,461.78. I would choose the lump sum today. How many marks? How many marks? 4. 4. With the explanation being one mark. Right. And whatever you found here, if you say, okay, I don't want to set myself up for failure and get used to a bigger life than I actually have, then I choose this. That's an explanation as well. And that's fine. You just have to explain it, what you choose. 4 marks. Yeah, nice. Kind of big, but I think you got it. Then we moved on to amortization schedules, right? And a part of that was finding, well, what was that monthly payment? Amortization schedules tend to be kind of long and tedious, and so I'm not going to make you do one on the test. Um, I didn't have one on the practice here, unless you really, really want one, but I don't think so. So we'll just do components of it. Compute the monthly payment for a house loan of also called a mortgage, I guess, of 200,000 to be financed over 30 years at an interest rate of 10%. And so let's see what we've got here. We want to find the monthly, which is 12 times per year. The monthly payment, which means that I'm solving for M. Now, the original amount that I borrowed is my P. Right? It's either my initial deposit or the value of these payments drawn back to today. But either way, it's going to be P is 200,000. To be financed over 30 years, T is 30. I have an interest rate of 10%, 0.1. Okay. If I want to solve for M, there's only one formula that lets us do that. Right? And so on our formula sheet, can't remember where I had it. Right? This is the only formula that lets us solve for well, I guess you could solve for it here or here. Fine, fine, I take it back. But if we have a P, it has to be this last one. Ah. So, there we go. Because what should the accumulated amount be at the end of a mortgage? 0. Right? So that's boring. Can't use that. Because you should have paid it all off. Unless you were borrowing. No, let's not do that. Let's not think about that. Jot down our formulas. P times 1 plus R over N to the N times T is equal to M times 1 plus R over N to the N times T minus 1 divided by R over N. All right. P is 200,000. And wouldn't that be so nice? 1 plus R, which is 0.10, divided by N, which is 12. 12 again times 30. We're solving for M, but everything else we have. 1 plus 0.10 over 12 to the power of 12 times 30 minus 1. Divided by 0.1 divided by 12. Okay, let's see here. Noticing again that this chunk, right, is the same as the chunk that we have over here, right? So if I solve for it and I store it, then I can cheat a little bit. I know. It's not cheating. Can save myself some time. Zero point 0.1 divided by 12 plus 1 to the power of 12 times 30. As long as you use brackets around the power of 12 times 30. You don't want to do to the power of 12 and then all of that times 30. That's bad. But if you make sure it's all in the power, then you can do that. So this becomes 200,000 times 19.83739937, which I'm going to store in A. Save it for later. Equals M, because now I can use it again by subtracting 1. And then I'm going to divide by 0.1 divided by 12. And I get times 2260.487925. I'm going to store that in B. Do you think I can remember it? Solving for M, right? I can solve for M by simplifying the left-hand side and dividing 2260 over to the right-hand side, but then I like to have what I'm solving for on the left, and so then I'll move it over here. So in one smooth move, recall A times 200,000. Count my zeros. 1, 2, 3. Yeah. I get 3967479.875. This step you have to show. Divided by 2260.487925. Divide by, recall B. I get 1755.14314. Or in monies, $1,755.14 every month for 30 years. There we go. Okay. We did it. How many marks? I want to do 3, but yeah, 3. How much work did we do? No, 3's fine. 3 marks. It was just because you had to explain the other one. Really bungs up my marking scheme, though. 3, 2.5, 2. Oh well. The Gomez family bought a house for $175,000. How cute. They paid 20% down and amortized the rest at 11.2%, yikes, over a 30-year period. And we have to find their monthly payment. This is the same as what we just did, with one exception, right? The down payment, which I included because no one liked it. So, just some more practice. This makes it our P. Our initial loan amount will always be P, all right? Because that's how much the bank has to put out for you to buy this house today. 20% down of 175,000. Okay. And so this means I shouldn't make this P paid total. And maybe I always find that it's easier if we draw these out, right? You might not, but that's okay. I'm still gonna do it. Let's say they bought a house today, or they bought the house today, and then 30 years later, they've paid it all off. And we want to find what their monthly payment is, right? 1 month, 2 months, blah, 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 for 30 years. 30 times 12 is 360 months. So then some amount M that we're trying to solve for, right? Find their monthly payment. Oops, not the monthly, but the payment. M. Monthly means that N is 12. And the rate is a whopping 0.112. And T is 30. Now what this means is that all these M's have to be worth 175,000 less the down payment today. So this is going to be worth some P. And then the down payment is 0.20 times 175. 0.2 times 175 is 35,000. Okay. So P plus 35,000 as the down payment that has to be 175,000. Which means that P, we have to do a little bit of work for P 175. You could do times 0.8 if you want it, right? But it'll be the same minus 35,000 is they got a loan for 140,000. Okay? And so therefore, P is 140,000. And that's going to be the loan amount. Okay. Now we're ready. Same formula as before, right? We have a P and we have an M, and we're trying to solve for M. And so let's use that same formula on our formula sheet. This one here. Doesn't need to be that big. There we go. Now it's all the same, right, as what we just did. It was just that additional work, right? Probably worth 1 mark. We'll see. P times 1 plus R over N to the N times T is M times 1 plus R over N to the N times T minus 1. This one, I'm going to move a little bit quicker because we just did it. just with different numbers. And so 140,000 is the loan amount times 1 plus, what was our R? 0.112 divided by monthly. Yes. For 30 years is M, which we're solving for, times 1 plus 0.112 divided by 12 to the power of 12 times 30 minus 1. Agree. Okay. I'm just going to go for it. 0.112 divided by 12 plus 1 to the power of 12 times 30, making sure it's all in the power. I'm going to store that. And then times 140,000. I'm just going to go for it, like I said. Because I'm also worried about time. But the last chapter 7's a lot quicker. 3968166.028 is M times A minus 1 divided by bracket 0.112 divided by 12. M times 2929.718899. B. I get an M of 1354.452821. Or in monies, 1,354.45. I think on the test, we only really need one of these M problems, right? Because they're the same. So I'm leaning more towards this one with the down payment. I wanted you to see both, right? To see that they're all the same. It's a practice test. But we'll do 4 marks here. Because you had to do that extra work to find the down payment and know to take it out of the 175,000 to find the loan amount. That's a lot of extra work. Huh? So 14 months after Dan bought his new car, he lost his job. This one's such a bummer. I don't know why I picked this one. His car was repossessed by his lender after he had made only 14 monthly payments of $376 each. If the loan was financed over a 4-year period at an interest rate of 10.3%, how much did the car cost the lender? In other words, how much did Dan still owe on the car? Huh? And so now, what does this look like? Right? Dan bought a car. Right? Purchased the car. He's making payments. Monthly payments, 1 month, 2 months, all the way up to 14 months. He made these payments of 376, 376, 376, and then it's repossessed. Uh-oh. But he had signed up for a 4-year period, right? And so 4 years from the purchase date is how many months? 4 times 12 is 48 months. So he'd committed to making 48 of those 376 payments, but he only made $376 payments, but he only made 14 of them. Um, and so, but they've been paid, right? So he's chipping away at what he owes. And so what happens is 47 months and these guys are all worth some present value today. But now T is going to be the time remaining, right? And I actually think it's easier to work in NT, right? NT is the number of compoundings remaining. Because we have a total of 48. We can deduct the 14, right? And so here, N times T is 48 minus 14. 48 minus 14 is 34 payments remaining. And so that's what we want to find P for, right? If we were to pull these payments all the way back to the purchase date, well, that's how much he paid for the car, right? And so, but now we want to say, okay, something happened, he's got to pay it back, or at least the lender has to pay it back. And so that's our new P. Okay. We've got our payment amounts of M is 376. And our N is 12. T is 4, but I'm not going to write down T is 4 because T is actually going to be 4 years minus 14 months, which is hard to think about. And so that's why I prefer the N times T is 34 payments. Okay. At an interest rate of 0.103. And then how much did Dan still owe on the car is your P after 14 months. Or at 34 payments remaining. So we've still got the same payment amounts that he's committed to. He just can't do it anymore. Okay. So our formula is the same one. You guys getting bored of that formula or what? Got to find our P. I'm just going to snag it from here because it's the same one. Jot it down. P times 1 plus R over N to the N times T is M times 1 plus R over N to the N times T minus 1 divided by R over N. We want to solve for P, but everything else we have. So 1 plus 0.103 divided by 12. 12 times 4 years, right? Aha, nice try. This has to be the time remaining, right? Not 4 years, but the time remaining. And so we already found that N times T, there were 34 payments remaining. You can still keep N as 12, but then you'd have to find 4 years less 14 months in years, which is kind of difficult, right? 48 minus 15, or minus 14, minus 15, minus 14, and then that out of 12, I guess. Too messy. Nice, thanks. Too messy. N times t is 34, which is $376 per month times 1 plus 0.103 divided by 12. N times t is 34. Again, I'll highlight that because that's the only curveball, really. Divided by 0.103 divided by 12. Okay, here we go. 0.103 divided by 12 plus 1 to the power of 34. Now, as long as you do that, then you're okay. I get P times 1.337213542. No, I know what you're thinking. Is that optional? Yes, I guess so. Store that. Because I need it here again. Right? Minus 1 times 376 divided by bracket 0.103 divided by 12. I get 14771.91751. So then P is 14771.91751 divided by 1.3372133542. Divided by A. Get a P of 11,046.79024. Or in monies, what he still owed on the car was 11,046.79. This one is tricksy because you have to remember that, okay, now n times t, or t is the time remaining, right? And for that reason, I would make it 4 marks. Oops, 4 marks. It's a heavy hitter. Still not that much work. How about this one? Uh-oh. Miss Garcia is planning to retire in 20 years. She starts to save for retirement by depositing $2,000 each quarter into a retirement investment account that earns 6% interest compounded quarterly. Find the accumulated value of her retirement savings at the end of 20 years. Okay, so she's making these deposits for 20 years and they will be worth something at the end of those 20 years, right? That first payment, that first deposit, quarterly deposit, right? It sat there for 20 years. And so that $2,000 is going to be a lot bigger than the more recent $2,000, right? So we need to take that into account. So we first need to find the accumulated value, okay? Because then, assume Mrs. Garcia has now reached retirement and would like to make equal monthly withdrawals for the next 15 years to completely deplete the account. So now she's basically going to be just withdrawing from that accumulated amount, right? And so kind of the change of in and out money policies. We're going to find the withdrawal payment. And now the account pays 5.4% compounded monthly. So the interest rates have changed. There's a lot to keep track of here. I do find that it's easier to kind of sketch it out, but I'll make it in the optional color because you don't have to. I think of these as a two-phase problem, right? And so first she's depositing money, and then that's going to grow to some amount, and then we're going to withdraw from that amount, and then we're done, right? But it's kind of working in two phases. Yeah. And so here we've got the 20-year mark. Yeah. So from here, today she says, in 20 years from now, I'm going to retire. Okay. And so here, retire. Whee! Smiley face. Although kind of a mean smiley face, I guess. Okay. She's gonna deposit $2,000 every quarter. 1 quarter, 2 quarters, up for 20 years. All right. 20 years, whoops, 20 years times 4 would be 80 quarters. Right, up to the 79th quarter. 2000, 2000, 2000. Okay. Now these payments are all worth some amount A when she retires. Okay. And I guess I should stack that. That wasn't very good. That A at the retirement party. Okay. Let's jot some things down. Here, my N is 4, and my T is 20, and my rate, because the rates are different, 6% interest compounded quarterly. My rate for this section is 0.06. Okay. I'll use green as my alternate optional color because I want to show that it's in two phases, phase 1 and phase 2. Because now you'll have an A. Now this is where it gets a little bit tricky to mark because I have to follow through. So whatever you use for your A is what you have. And how are you supposed to know? Okay. She's going to make equal monthly withdrawals for the next 15 years. Now I'm going to put this at 15 years because the 0 point is the retirement. And for 15 years, monthly payments, that's 180 months. So here, month 1, month 2, 179 months. She's getting some amount, M. Okay. Those are going to come from some present value, P. But here, our N is monthly payments, our T is 15 years, and the rate is 0.054. And then the key component here is that these have to be the same. Right? So whatever you found for your A has to turn into your P, and then you can solve for M. Okay. And I did not highlight what all the things are. That's okay. See you. Let's see here. Okay. Everything's riding on you now. I need a page. For phase one, let's call this phase one. And let's call this phase two. For phase one, we need to find the accumulated amount, which means we're using, it's been a while since we used this one, here, right? A is the accumulated amount. Copy. Oh, it's so far. I'll jot down phase one here. We want to solve for A. So A is m times 1 plus r over n to the n times t. Isn't it so nice to go back to this itty bitty one after we've been working with the Mumba Jumba? A is, it was $2,000, 1 plus, and the rate was 0.06 divided by quarterly, or 4, to the power of 4 times 20 years minus 1 divided by 0.06 divided by 4. Okay, let's do this. 0.06 divided by 4 plus 1 to the power of 4 times 20, keeping it in the power, minus 1, times 2,000 divided by 0.06 divided by 4. I get an accumulated amount of 305,421.7049. Or in monies, 305, oops, 5421.70. Ah. Phase two. Now this becomes our P. P is equal to this 305,421.70. And now I want to solve for M. Okay. Keeping track, I've got a different interest rate and a different payment and compounding frequency. And so let's snag that. And I need the formula that we've been using a ton here. Okay. So I've got my P, which has to, whoops, sloppy. I'll jot down my formula. M times 1 plus r over n to the n times t minus 1 divided by r over n. Now I can plug it in. 305,421.70. And like I was saying, of course, if you got the wrong value for that A, but you carried it through, that's fine, right? You don't get the marks for finding A, but you can still keep full marks. 1 plus, now the rate has turned into 0.054. 0.054 divided by 12 to the power of 12 times 15 years is m times 1 plus 0.054 divided by 12. 12 times 15 minus 1. Sneak that in there. 0.054 divided by 12. Okay. .054 divided by 12 plus 1 to the power of 12 times 15. I'm going to store that. Minus 1, taking it over here, minus 1 divided by .04 divided by 12. Or sorry, .054 divided by 12. Just gonna go for it. Oops, yeah, okay. Maybe. 305421.7 times, call it. I get 685313.4972. And I need to remember what that other one was, divided by 276.406029.4. Hopefully I didn't flub that somewhere. Ugh. And I find an M of 2479.372461, or in monies, 2,479 and 37 pennies per month. This feels like a 6-mark question. Wow. There's a lot of components. Or should I make it 5? How confident are we feeling? Considering I'm only looking at one face, I can't read anyone else. Got so much power. If you feel confident, 6 is the way to go. If it's not feeling that good, should do 5. 5. Keep it nice and reasonable. Oh, that makes it look like that part is 5 marks. No, let's do it up here. 5 marks. Okay. I am almost out of time, but luckily the rest doesn't take very long because now we're into sets and counting, and that's all fun and games. Remembering that this is the intersection, right, or an and, right? It kind of makes an A, right, if you draw a line through it. And so the elements in the set of Al, Bob, Chris, and Dave, and Bob, Chris, Dave, and Ed are at the intersection. And so it's going to be Al is not in the second set. Bob is in the second set. So Bob. Chris is in the second set. So Chris, Dave, and Ed is not in the first set. And that's 1 mark. All right. Then we can step it up a notch and we can say, okay, well, if I have a universal set, which is all the numbers between 1 and 10, and A can be 1, 2, 3, 4, 5, and B can be 1, 3, 4, 6, and C can be 2, 4, 6, then we can list the members of this more complicated group or set where we need A or B, but the complement of that and C. Okay? And so what we're going to do is we're going to work in phases, and we're going to find, first I find A or B. Okay? And then I'm going to find the complement of that, which is everything in the universal set that's not in A or B. Okay? And then I find it at the intersection with C. Okay? So first, A or B is the set of, it has to be an A or B or both. So 1, 2, 3, 4, 5, 6. Then the complement of that, A or B, the complement has the bar over it, is everything in the universal set that's not in A or B. Okay? And so we can pick up 7, 8, 9, 10. 7, 8, 9, 10. Okay? And then we want that set with the intersection of C. I see that there's no elements in common. That's okay. That just means what? It means that the complement of A or B and C is going to be the empty set. Because there's no elements at the intersection. Okay. I know that's my time, but I am gonna keep going, but I do understand if you have to go because that's the end of class time. But just for a complete video, I'll keep going. But I understand if you have to go. Okay. And I'll see you on Thursday. So, in Mrs. Yamamoto's class of 35 students, 12 students are taking history, 18 are taking English, and 4 are taking both. First, we're going to draw a Venn diagram to find the number of students in each region of the diagram. So whether we use it or not, I want to see all the regions filled in. So we can take history, we can take English, or we can take both. So, part A. My Venn diagram has to have 2 sets. History or English or both. And I've got my universal set out here. Now, whenever we're working with Venn diagrams, you always want to start in the center and jot down the number in the center and then take that away from the remaining parts. Okay, and so we have 4 here that are taking both. And 18 are taking English, which means that 14 are only taking English. And 12 are taking history, which means that 8 are only taking history. And then the remaining 35 students, less 35 minus 8 minus 4 minus 14, makes 9 students that are taking neither. Which answers are part B? Right? How many students are taking neither history nor English? And for this, you can just jot down 9. This is 1 mark, and this is 1 mark. All right, can you read it? Can you make it? Can you read it? Okay. Can do the same thing, but with 3 sets, right? And so now we have math, English, and history. And so we need to draw a Venn diagram. So and that Venn diagram has to take into account all 3 of these sets. 1, 2, 3. We can have math, we can have English, and we can have history down here, and the universal set. So we have to find the numbers in each region of the diagram. And again, we're going to start at the very center here. 5 take all 3 subjects. So I'm going to jot down 5. And then I'm going to peel away at these layers, but you want to make sure that you work from the center out into, I call them the petals, and then into the final pieces of the circle. Okay? And so 15 take English and math. English and math happen here, right? But we've already got 5 of those 15, making 10 here. 10 take English and history, but I've already got 5 of them accounted for, and so that means I have 5 here. And 10 take math and history, which means I have another 5 here. And now I can take those parts all out of the overall. So 50 take math, which means that 50 minus 10, which makes 30. Okay. 40 take English. 40 minus 10 makes 20. And 30 take history, right? That whole circle has to add to 30. And so I get 15, right? 15, 20, 30. Nice. And now I also have 100 students total, right? So my universal set has to add to 100. And so on the outside here, I have 100 minus all these components. So 100 minus 30 minus 10 minus 5 minus 20 minus 5 minus 5 minus 15, unless I did something weird, which means 10 are on the outside. Find the number of students taking math, but not the other two subjects. Right? And so that's just this area here. And again, because everything hinges on it, as long as you follow through with what you have, right? This is really only going to be 1 mark because just try your best. The number of students taking math, but not the other two subjects, that's 30. How about I just do this instead? 1 mark each. It'll feel disproportionate with the Venn diagram taking so much time. But the reason the other ones are so quick is because you've already done the Venn diagram. How many students are taking English or math? So they can be in this circle or this circle, but not history, which means they can't be in this circle here, right? I see 30 plus 10 plus 20. You don't have to show it, but you do have to say the total, which is 60. How many students are taking none of these subjects? Well, we already did all that work, and I see 10. For lunch, a small restaurant offers 2 types of soups, 3 kinds of sandwiches, and 2 types of soft drinks. Use a tree diagram to determine the number of possible meals consisting of a soup, a sandwich, and a soft drink. So I have 3 things that I need to deal with here. It does say use a tree diagram, so we're going to do it. I've got 2 soups. Soup 1, soup 2. That doesn't work because then it's sandwich. Okay, fine. 3 kinds of sandwiches. Sandwich 1, sandwich 2, and sandwich 3. Sandwich. I'll call them SA1, SA2, and SA3. Just for sandwich. And then soft drink. How about I call that D for drink? 2 types of drinks. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Soft drink. Drink 1, drink 2, drink 1, drink 2, drink 1, drink 2. Whoa. Drink 1, drink 2. Drink 1, drink 2, drink 1, drink 2. Luckily, it only asks for the number of possible meals. This would have been a lot easier with the multiplication axiom, right? 2 times 3 times 2, but we should get the same answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 combinations. 2 marks. It would be 1 mark if I didn't make you do the tree, but the tree's worth something, right? Kind of being able to lay it out. And if it asks for a tree, you have to do a tree. How many 7-digit telephone numbers are possible if the first 2 digits cannot be ones or zeros? So this is one of those where we use our slots, right? Because we can have repeating numbers, that's allowed. We've just got some restrictions on our 7-digit phone number. So I've got 1, 2, 3, 4, 5, 6, 7 digits. And the first 2 digits, not 0 or 1. But in general, I have 10 digits to choose from, but I've got restrictions on those first 2. Which means I have 8 options and 8 options and 10 and 10 and 10 and 10 and 10. There. Which is going to be a large number of phone numbers. 8 times 8 times 10 to the power of 1, 2, 3, 4, 5. To cheat a little bit. 6, 4, 1, 2, 3, 4, 5. 2, 3, 4, 5. Zeros. Now you have to determine the different possibilities. But luckily, a coin is tossed 3 times, and a coin only has 2 possible outcomes, right? Heads, tails. We ignore the on the side outcome. 3 times. Okay, so first toss, second toss, third toss. So our first toss, I'm going to give myself lots of room here. Toss 1 is either heads or tails. Toss 2 is either heads or tails. And the final toss is also heads or tails. Heads or tails. Heads or tails. Heads or tails. Toss 3. To find the different possibilities, I record the sequence of events running down the tree. Heads, 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 tails, heads, tails, heads, and so on and so forth. Heads, 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 tails, head, tail, heads, head, tail, 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 head, head, tail, head, tail, 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 head, tail, 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 tail. There. A group of 15 people who are members of an investment club wish to choose a president and a secretary. How many different ways can this be done? Now, the key is that a person who's chosen to be president cannot also be chosen for secretary. Right? So I use my slots. I've got my president and a secretary. I have 15 people initially that I could choose from, and so 15, but then I've used one up as the president, and so then I elect a secretary. Oh. And so 15 times 14 is 210 ways. Ooh, I forgot to do marks for this one. Whoa, the past 2. Well, this is obviously, the phone number is obviously just 1 mark. And the tree diagram, 2 marks. One mark. Because they're just itty bitty. Little quickies. We're talking about permutations, and so permutations of letters or in a word. are pretty common questions that we could have. And so how many permutations of the letters of the word security end in a consonant? Okay. So first, we need to use up all the letters. That's implied. And we have 1, 2, 3, 4, 5, 6, 7, 8 letters. They're all unique, so that's nice. 1, 2, 3, 4, 5, 6, 7, 8 letters. They have to end in a consonant, which means that I can use, and let's assume what's typical? Y is a consonant, right? A, E, I, O, U, and sometimes Y. I don't know when it is. So let's assume it's a consonant. Doesn't matter. I've got 1, 2, 3, 4, 5 consonants. Therefore, 5 consonants. Which means I'm going to start and pick away at my conditions first, right? I need to force that last letter to be one of those 5. And I've got 5 choices. Okay. But that also means that I've used up one of those 8 letters. And so when I start over here, I only have 7 options, right? Instead of the original 8. So I have 7. And then if I've used up that letter, I only have 6, and then I have 5, and then I have 4, and then I have 3, and then I have 2, and then I have 1 option. And we multiply through. 7 times 6 times 5 times 4 times 3 times 2 times 1 times 5. Kind of did it fast though. 25,200 different permutations that end in a consonant. I'm going to say this is 2 marks because it's a little bit more involved, right? Force this to be a consonant. Force this to be a consonant. Our last question. I know. Wow. I blab a lot. A bakery has 9 different fancy cakes. In how many ways can 5 of the 9 fancy cakes be lined up in a row in the bakery display case? So we can make that row of cakes. 1, 2, 3, 4, 5 cakes. I have 9 initially that I could put in the first spot, but then I've used that up, and so then I have 8. And then I have 7, and then I have 6, and then I have 5, which means I have 9 times 8 times 7 times 6 times 5, which is 151.20, which is going to be 1 mark. But it's a little bit more involved. Hi, Pup. The dog's home, just in time. And she's going to be too excited. Here. Here she is. She's like, whoa. There. And I guess I'm done. And then there's a bonus 2 marks on the combinations, but I didn't give you any practice on the combinations. You can do it. They're from the textbook. So, all right. If you have any questions, let me know. But it looks like you're the only one who's left. So I'll stop this recording.
You.
Thanks for sticking around.
Of course, it makes it easier because then I get it done.
See you.
See you. Have a good night.